Well, hello there. Let's do part 2. Okay, now we're dealing with the quotient property. So multiplication, so the product, if they're multiplying, they're adding. Here, if they're dividing, they are subtracting. So in this case, it's the numerator minus the denominator there. For all of these, they all have the same base. So always be mindful of the base. Here, example 4. So the log base 4 of 6. They want us to solve for this, but they want us to use the log base 4 of 48 and log base 4 of 8. So here, another way I can write this, log base 4 of 6 is equal to the log of 4, they both have the same log, of 48 divided by 8. So your two numbers there that they want you to use is those two there, because 48 divided by 8 gives you your 6 from what you started with. So you're going to kind of look for different numbers that equal 6. So here, they want us to use 48. They want us to use 8. So we have log base 4 of 48 divided by 8. So now we go ahead and simplify it. And we get, just to make sure it is right. Here, when they're dividing, we want to make sure that we put it in terms of subtracting. So now we're going to kind of undo them. So log base 4 of the numerator, which is 48, minus log base 4 of the denominator, which is 8. So therefore we have it, we had division, we're going to put it in terms of subtraction. When we put it in terms of subtraction, we have what log base 4 of 48 is. And that's given to us right here, 2.7925, minus log base 4 of 8. And again, that's what they gave us over here, which is 1.5. So to solve for these, you simply subtract. And when you subtract, you get 1.2925. You can check your answer by doing the base. So log base 4 of 6. So you can do log 6 divided by log 4, and you'll end up with the same answer there. B, now we're dealing with natural logs. Here it says natural log of e to the 4th power divided by 3. They are dividing. So therefore, if they are dividing, we're going to put them in terms of subtraction. You always want to do that. You kind of want to make them larger. We're trying to put it in terms of addition and subtraction. Now, here we have numerator and denominator. We're going to go ahead and separate them. The numerator is e to the 4th power, so the natural log of e, minus the natural log of the denominator, which is 3. Each term in these cases have to include a log and a natural log. So here, natural log of e to the 4th power minus natural log of 3, which is what we're going to solve for here. But if we're looking at this natural log of e to the 4th power, if we go back to the first rule here, just like the inverse property, all of these, if you have the same numbers, they're side by side, the base and the main number are the same, they cancel out. But if you have a natural log and an e right next to each other, they actually cancel out and equal 1. So here, we have natural log of e to the 4th power. We're using that inverse property for them to cancel out, and all we're left with is the exponent, which is 4. And then minus the natural log of 3, if you see here, that's what they gave you. And that is 1.0986. After that, you go ahead and subtract. And when you go ahead and subtract, we get about 2.9014. So I think I put it in your homework to round to a certain place number. If not, I always check through the answers to make sure if it's just off by a decimal or 2, I go ahead and correct it. But just make sure you're following these steps step by step. If you're actually doing these and following along, this can be very essential for you for next year. Power property. That means, this is one of my favorites, very easy. When you're multiplying, you add. When you're dividing, you subtract. When you have a power, so log base b of a to the p power, this exponent now becomes a number in front. So here, this p moved from the exponent all the way to the front. So here, it says to simplify the log base 3 of 81 squared. This 2, now we're going to go ahead and move it. So if we move it, we have 2 log of 3 to the of 81. So now we have that there. They want us to start solving for these. So let's look at the log base 3 of 81. If I put this in regular logarithm form, I have log base 3 of 81 equals y. right? So they have this, they have logarithm, it's that equal to whatever number. Now they want us to solve for it because we could solve for log base 3 of 81. If we put this in exponential form, so this goes back to this, if we want to screenshot this or go back to the lesson, that right there. In exponential form, this, your base becomes your main number. Your base is 3. Your solution becomes your exponent, so 3 to the y power. And your main number becomes your new solution. So we have 3 to the y power equals 81. For this, try to play with your calculator. 3 squared is 9. 3 cubed is another answer, is 27. 3 to the 4th power does give you 81. So that means y has to equal 4. So in this case here, we can solve for the logarithm automatically. And we get 4. And now, to solve for this, you go ahead and multiply the 2, and you end up with 8. Now here, and it's only for some cases, you can try to work them out for all the other ones and see if they actually give you an answer. Sometimes it will, sometimes it won't. Now here, write the natural log of this as a sum and difference, so it has like an actual equation. We're expanding it. So here, the natural log of 5e over x squared. We have several things going on here, but the main thing that's going on is the squared. This squared is being applied to that fraction, so then we're going to use the power property first. So it's kind of like working backwards. You use a power property if there's any exponents, then use a quotient if there's any fractions, then use a product if they are multiplying. So it's kind of working backwards. So here we have the 2, we're going to go ahead and move it forward. So we're going to have 2 times the natural log, actually I'm going to take that out, 2 times the natural log of 5e over x. Next thing, there's no exponents anymore. Now we look at the quotient rule. Quotient meaning if there is a fraction, we go ahead and put in terms of subtraction. So now, to put in terms of subtraction, we're going to go ahead and just leave this 2 out for now. So we're going to have it as a big equation here. So we're going to have the natural log. If it's a fraction, we are subtracting the numerator by the denominator. So the numerator is natural log of 5e. The denominator minus the natural log of x. So include that natural log or log. So we have 2 times the natural log of 5e and the natural log of x. We're not done here, so there's no fractions. Now we go to the product property. Are there anything that's multiplying? In this case, we have this term here. They're multiplying 5e, 5 times e. So I can put it in terms of 2 times the natural log of 5 plus the natural log of e minus, and then we just include that next there. So this turns into 5 plus e. If we look here, we know that natural log of e cancels out. And the natural log of e, we're using the inverse property, is equal to 1. So we have 2 times the natural log of 5 plus 1 minus the natural log of x. And the last step, you could do this, you don't have to do this, is you're applying distributive property. And now that 2 that we left on the side, we're going to go ahead and multiply everything now. So now 2 times the natural log of 5, we get 2 natural log 5. So it just becomes the number in front. You're not multiplying into your 5. 2 times 1 gives you 2. 2 times your natural log of x gives you negative 2 natural log x. It's only multiplying to the numbers in front of the log and natural log. Now, the very last step is to solve for these type of equations. This is where logarithms come to play. You see them a lot in pre-calculus. Here, we have this equation. They gave us what m is, and they said later on m is equal to 7.1. It's a word problem. You can read it on your own time, pause it, and then read it, and then look at it. Here, they gave us what m is. They want us to solve for e. To do that, we have to do a lot of different properties to get the e by itself. So first thing I did, substituted 7.1 for the m. Now let's go ahead and try to solve for this. It looks like here, to get the e by itself, I need to get at least the log by itself. The log isn't by itself in this case. I can multiply this whole thing by the number in front, the reciprocal of 2/3, and that is 3 over 2. So I'm multiplying to both sides. So on the right side, I have log of e over 10 to the 11.8 power, 3 over 2 times 7.1. I get 10.65. Now, the e, I could get it by itself, if I follow one of the properties, and it's a fraction, so that means I can put in terms of subtraction. That rhymes. 10.65 is equal to log of e, capital E, minus the log of 10 to the 11.8 power. So, if it doesn't have a base, remember the log is automatically the common log, which is base of 10. So if we go left to right, this is good. Log of e, that's good. Minus log 10 to 11.8 power. All of these log is a common log, and that means it's the common log of 10. These numbers are exactly the same, so that means they cancel out using the inverse property. So now we have 10.65 is equal to log of e, we're not going to write the 10 down, minus, and now what you're left with is your exponent that you had, and this is from example 1 examples. Now we have this here. We're still trying to get the e by itself, so just like when you're doing an equation, try to get rid of any terms that are adding or subtracting into it. This cancels out, and you're left with 21 point, I think it's 22. Yep, 22.45 is equal to log of e. And now, from this step here, we can't go any further. We can't do the inverse log. We can't do anything like that. We're going to go ahead and put this in exponential form. You can't do anything else. We can't use any of these 4 properties. So now we put it in exponential form. Again, that's what I have here. You can screenshot that or whatever. So now, so let's just put it in terms of what we usually see. Log of e is equal to 22.45. According to exponential form, we're going to go ahead and have our base as our main number. The base of this log is 10. And then your exponent is going to be your solution from before. It's considered the y in that equation, and that is 22.45. So if you did that worksheet, this is where this worksheet will come in handy because you're practicing and practicing. And it's 10, so your base to your solution, so that's the power right there, is equal to your main number. Your main number here is e. So in this case here, all we have to do is simply solve a simple solution by using our calculator. So we do 10 to the 22.45 power. We end up with this huge number there. So I think the book rounded it to the 10th place. No, the 100th place. So here's 2.80, and they rounded that to 2 times, in the bottom right there says 10 to the 22 power. So we're going to write all of that there. So the e is equal to 22.82 times 10 to the 22 power. And that's exactly what you have in your calculator. If you need more help, let me know. You take time to work these problems out. Again, very useful for next year. I love working with logarithms. Once you understand them, they get a lot easier as the days go by. I'm gonna see you guys.